Hello guys, today we're gonna learn more into operators in Verilog. We already covered different types of operators. We learned what is the operator. For that, please prefer the previous videos, tutorial 7 and tutorial 8. And today we're gonna see what is a concatenation operator. So before that, I will brief you about the previous operators, what we did. So these are the different types of operator that are useful in implementing your logic. So arithmetic is done, then bitwise is done, and shift operation is done. Today we will see the concatenation operation, and the replication operator is also similar to that only. So we will cover that also. So in the arithmetic, I took example of this multiplier. Okay, and for that bitwise and bitwise implementation logic, I used an example of mux. So you can go through the previous videos and look into it how the following operators can be implemented, and that knowledge you can use to implement different exercises on Verilog, Xilinx, ISC design suite. So concatenation operator, so it provides a mechanism to append the multiple operands. So the operand must be sized, means you cannot randomly define a infinite operand. It should be finite and it should have some constraint size. So unsized operands are not allowed because the size of each operand must be known for a computation of the size of the result. So for that, I would like to give you one example what this braces means, and then we can go and switch to the coding part. So I'll take my whiteboard for that. Okay, so suppose you are concatenating some a and b variables, and suppose you in module you have defined a, b and c, where input is A, B, and output is C. So you need to take output such that it is a combination of A and B. So what you will write, you will assign C is equal to A, B. Okay, so if you have already defined here the values of inputs A and B, suppose A is equal to 1 and B is equal to 0, then your C will be equal to 1 comma 1 sort of concatenation, and your answer will be 1 1. This will be your final answer. So this is how concatenation is done. One more example we can see, that is if A is equal to 2 bit 1 0 and B is equal to 3 bit 1 1 1, and if you are performing this operation, then the result of your C would be equal to 1 0 1 1 1. This would be the final result for this operation. Fine. Now we will switch to the coding part, and let's see how to implement by using a different example I would show you. Okay, so let's switch to the coding part. So now guys, switching to the coding part. So I have created one file with the name concate. You can simply create it by using a new source and next finish. So this is one of the example code we will run and see. Okay, so here I will define the maximum number of bits that y can store. So maybe I can define from, 11 to 0, 12 number of bits it is storing. Just for example, let's save it and then let's run it. So it is done. So let's simulate the behavioral model of this concate file. Um, so right now we are concerned with B and C. So let's see. So why it is initially only giving list of the bits as 0, 0, 0, 0, 0? Because we are only concerned with B and C, that is the total number of bits with B and C are 3 plus 2, 5. So there are 1, 2, 3, 4, 5. 5 Zs are given. So other than the defined, if it is going beyond the defined bits, then those bits are termed as 0 bits. So that is also a very good point to note over here. So let's give this as 111 I, okay, and this I am giving as 0 1 0 and 1. So apply, okay, and then run it. So yes, first we are getting B 111 and then we are getting C 0 1. So here we have seen one of the example of concatenation operator. I hope you are clear with it. Let me give some more example. So I will close this. Yes. To check all this different type of implementation of concatenation operator, I am defining more number of output variables. Let me define a P and Q also, so that then I need to define it over here also, P and Q. So inputs are done, outputs are done, and let's assign P and Q with some other operation. So P is equal to, I am giving as A, B, C, D. Okay. So let me first count how many bits it would be. So it would be 5 into 7, 7 and 3, 10. So yeah, it will be covered in 11 is to 3, 11 is to 1. So that is fine. And then we can go to EQ, and there I am defining it as A, then first bit of B, or C, zeroth bit of C, and one more I am defining it as 3 bit of 110. So let's see different outputs. Let's save it, run it. So that is done successfully. Now let's simulate it. So this time we will be giving all the inputs. So let's say for A I'm giving 101, okay. Then for B I am giving 001, okay. Then for C I am giving 00. For D I'm giving, let's give 11100 and okay. So let's run it and see. So now you can see that in D, A, B, C, D were the inputs, and Y, P, Q are the outputs. So as Y, P, Q were assigned as 12 bits, so remaining extra bits will be termed as 0. And then here P gives a 10-bit result. So let's see what was it. So my P was A, B, C, D all combined. So you can see that 101, then 001, then 00, and then 11100. So that there were some extra bits that cutted or down off that supposed to be here. That is 101. So that was A. Then 00 was your C. 001 was B, 00 is your C, and 11100 is your D. So P was altogether 13 bit, but only we have assigned P as a 12 bit of inputs. That's why it is taking 12 bits. And Q was A and B first bit, C the 0 bit, and 3 bit of 110. So you can see here, sorry, so you can see here A, B first bit, C 0 bit, and 110. So guys, I hope you understand well how the concatenation operators can be used for different forms of logical implementation and operations. So in the next tutorial, I will be covering the replication operator that is very much similar to the concatenation only. That will be quick for you to understand. If you have understood this tutorial very well, then replication is very simple for you. So please do like and share if you like the learning part. Guys, please do support and stay tuned for more such tutorial, and do comment in the comment section if you wish to learn more exercise on or more modules in this Verilog platform. Till then, stay safe and thank you so much.